morning, children. Today we will discuss about line coding. Let us go with the presentation. Line coding and its characteristics. Line coding and its characteristics. Let us see what is the process of line coding. Now let us consider the binary data. So what is the binary data we have? It is in the form of zeros and ones. That means here the process of converting binary data to a digital signal is nothing but line coding. Here, the process of converting binary data to a digital signal is called line coding. Now let us see. So here this is the binary data. Zeros and ones. 0, 1, 0, 1, 1, 0, 0. That means here this is the binary data, and this binary data is converting into digital signal is nothing but line code. Now if you pass this binary data through the line coding, it will result into the digital signal. Now let us see it here. So here this is the digital signal, and here this is this axis along time, and here this is along amplitude, and here this is the amplitude here. Here amplitude is constant, and here we have the binary data zeros, ones, and here if I transmit 0, if I transmit 0 with the constant amplitude A, so here it is in the here at it 0 plus here, and if I pass 1 voltage through this amplitude A, and here we will obtain here a pulse here, and again 0, it is at 0 and 1, so here amplitude again we will see, and here again 1, so again we can observe the amplitude here in at A, and here we have 0 0. That means here we can see here 0 0. That means here the process of converting binary data into digital signal, it is nothing but line coding. That means here A is constant amplitude. Now let us see some important characteristics of line coding. So here we have signal level and data level, pulse rate and bit rate, DC component, self synchronization. So these are the important characteristics of line coding. Now let us see first one, signal level and data level. So here signal level and data level. What is signal level? So number of values allowed in a particular signal is called number of signal levels. That means here number of values allowed in a particular signal is called number of signal levels. We will see in the diagram. And data levels. So number of values to represent data is called as number of data levels. That means if you consider binary data, so here we have only zeros and ones. So the data levels are 2. If you consider octo system, so that we will obtain here 8. That means the binary data it will be 8. But here we have considered binary, so it is 2 for octo data. If we consider octo, so we have 8 values, and let us see the diagram. So let us see the example here. So here, if here the data it is binary data it is 0 1 0 1 0, and the here another data 0 1 1 0 1. So here the data levels we are considered here binary system, so data levels it is 2, and here also the binary data, so it is also data levels 2. So here the process of converting binary data into digital signal is nothing but line coding. So here at this particular point it is signal it is 0, and here it is positive amplitude. So here for 0, so it is represented here 0, and for 1, so here we have pulse, and for 0 it is down, 1 again it at particular A amplitude, and 0 here. So in the same way, so here it is 0 and 1, it is at positive A, and if you consider another one side by side, again it is minus A, sorry it is minus A, and 0 again 1, it is 1. So here, so data levels for binary system it is 2, and here we have signal levels 3, and here we have signal levels 2. So this is about data levels and signal level. Next, let us see the pulse rate and bit rate. Let us see pulse rate and bit rate. So here pulse rate, it is nothing but number of pulses per second. Number of pulses per second is nothing but pulse rate. So a pulse, what is a pulse? Pulse is nothing but the minimum amount of time required to transmit a signal. Pulse is defined as minimum amount of time required to transmit a signal is nothing but pulse. Pulse rate is nothing but number of pulses per second. So what is bit rate? So bit rate, it is defined as number of bits per second. So bits means we have binary digits 0, 1, 0, 0. So all those comes under bits. So bit rate is nothing but number of bits per second. And if one pulse corresponds to one bit, one if you consider a single pulse, it corresponds to a single bit, then pulse rate equals to bit rate. But pulse carries more than one bit. If pulse carries more than one bit, so pulse rate is lower than the bit rate. So that is we can represent bit rate equals to pulse rate into log L base 2. That is equals to pulse rate into, so this one, m. So where L is equals to 2 power m. L is nothing but here 2 power m. L is 2 power m. So pulse rate into this is m. So here m is equals to number of bits per sample. M is number of bits per sample. So like this we can find out the bit rate. So this is about pulse rate and bit rate. Pulse rate means number of pulses per second. Pulse is nothing but minimum amount of time required to transmit a signal. Bit rate, it is defined as number of bits per second. So this is about bit rate, pulse rate. Now let us see DC component. So here, what is DC component? Here we can see. So over one cycle period of a waveform, if all the positive voltages are cancelled by negative voltages, then DC component of the waveform is 0. That means here, if you consider any cycle period of a waveform, if all the positive voltages, already here we have seen, let us see here, let us see here. Here, this is the, let us consider it is the zero component, zero DC component, and this is positive DC component. And here, if you see over one cycle period of waveform, so this is a waveform. If all the positive voltages, so here we have positive voltage here 1 and 1, and here we have negative voltage here 0, 0. That means here if all the positive voltages are cancelled by negative voltages, then DC component of the waveform is 0, because here we have considered here this is time and here this is 0, this is minus amplitude, amplitude minus a, then below this time axis, and above the time axis it is positive amplitude, and here here we have the negative voltages here, and here we have positive voltages. That means here positive voltages is equals to negative voltages. So when these get cancelled, waveform DC component is 0. And here we don't have any negative amplitude, so all here we have positive, so positive component, DC component. So here 0 represents the 0 voltage and 1 represented plus a voltage, and here this is positive component because we don't have any negative sign here, so they're not get cancelled. So this is the positive DC component. So here in the line coding, signal with non-DC component, here this is a signal with non-DC component, it is treated as the distorted one, and it can create errors in the received signal. That means here this is 0 DC component. If you consider non-DC component, so it can be distorted or it can create errors. But here for DC 0 DC component, here we have to consider the 0 DC component to get the good results. So the signals with DC component cannot pass through a transformer. So signals with 0 DC components are preferred. So if we have non-zero DC components, we cannot pass through the transformer. So that here the signals with 0 DC components are preferred. So here this is the preference. So for this we have to give the preference. Okay, this is about 0 component. Now next let us see the self synchronization. Self synchronization. So here if the receiver receives the bit intervals. So if the receives bit intervals correspond to the exactly to the senders, that means transmitter, receiver, transmitter. Here we have two components. Here for the self synchronization, here we have the main components are receiver and transmitter. Suppose if you consider the receiver's bit intervals corresponding exactly to the transmitter or sender's bit intervals, only it is possible to receive a signal correctly. That means what will happen if you send the signals with one data, and if it is the transmitter have another data to receive, so that it is not possible to receive the correct signal. So that here the receiving bit intervals should be equal to the transmitter bit intervals. So here the clock frequency, if we consider tx means here transmitter, and r it is receiver. So the clock frequency of tx and rx should be same. Why? Because the bit intervals for receivers and the bit intervals for the transmitter should be same. Otherwise, it is not possible to receive the signal exactly or correctly. That means here, if the clock frequency Tx and Rx are different, so data of Tx and Rx will be different. They won't be equal. So to match the data at Tx and Rx, clock frequency should be same and synchronized. So here this is the synchronization. So that means whenever we are sending the data with some bit intervals, the receiver should also have the same bit intervals. Then only it will get synchronized. So synchronize, it means synchronization. It is nothing but to make exactly simultaneous with the action. So here the transmitter and receiver bit intervals should be equal. Then only we can synchronize. So then only it is self synchronization. So this is about line coding. Thank you, children.